Welcome back, guys. So, continuing with our chapter on number systems, right? So, yesterday we looked into the different types of the collections of numbers that we have, right? Natural numbers, we defined about natural numbers, we defined whole numbers, we defined integers, we defined the collection of rational numbers, right? So when mathematicians researched, they found certain numbers, right, which are not rational numbers, meaning we know that rational numbers can be represented in the form p divided by q, p by q, where p and q are integers and q not equal to 0, correct? But there are certain numbers that cannot be represented in the form p by q. So this was basically discovered around 400 BC by the followers of the famous Greek mathematician and philosopher Pythagoras, right? So they figured out, right, that there are certain numbers which cannot be represented in the form p divided by q. Okay, so to give you an example, assume or draw a square, right, a small square of size 1 centimeter. Okay, so you call this square as ABCD. Okay, we are calling this square as ABCD. Now bifurcate this square into two right angled triangles. How will you do that? You just have to draw the diagonal BD. Okay, so you have ABCD, draw BD. So you have two right angled triangles, ABD, and another right angled triangle is BDC or DCB. Okay, this is another right angled triangle. And what is the base of the right angled triangle? You have DC as the base, you have BC, right, as the altitude, right? So the the measure of the base as well as altitude is 1 centimeter each. Okay, so you calculate the hypotenuse. How do you calculate? We have learnt about Pythagoras theorem in our 7th standard itself. What is that? Hypotenuse square equal to base square plus altitude square. This is true for all right angled triangles. Okay. So here the hypotenuse is BD is a hypotenuse. So BD square is equal to the base square, DC square plus CB square. So what is DC? 1. Okay, so DC square is 1 square. What is CB? It is also 1. So CB square is 1 square. Okay, so hypotenuse square DB square is equal to 1 square plus 1 square, which is equal to 1 plus 1, 2 centimeter square or meter square, whatever be the unit. So hypotenuse square dB square is equal to 2. Alright, 2 centimeter square. Now what is hypotenuse? dB is equal to square root of 2. Right? Now the square root of 2, if you try finding out the square root of 2 using long division method, right, you will not get to a state where the remainder will be equal to 0. It will never end, so you will get a kind of a decimal where 1.41, a lot of numbers will keep repeating. All right, which means the decimals will not terminate. At no point in time when you try finding the square root of 2 would you get a remainder as 0, because only when even when you assume when you apply the long division method, somewhere you have to get a remainder 0, right? Then only you can say, okay, the square root of 2 is the quotient, right? So in case if you have any doubt about the long division method to find square root that I am talking about, please go to my video on the 8th standard squares and square roots. There I have clearly explained about long division method. Okay, so such numbers where decimals do not terminate, do not end, and they also don't recur, which means that you cannot find any pattern. To give you an example, if you identify 10 by 3, you calculate 10 by 3. What is 10 by 3? It is 3.333333. So at least you can say it is also do not terminate, but you have 3's repeating after the decimals. But in the case of square root of 2, you after the decimal you cannot find any pattern. You cannot find a block of numbers recurring or any one number recurring, and the decimals will not terminate. Okay, so such numbers which are not rational numbers, the followers of Pythagoras named as irrational numbers, right? So what is the opposite of responsibility, right? If somebody has to comment on you saying that you are not responsible, how would they say that you are highly irresponsible, right? So the opposite of responsible is irresponsible. Similarly, they said this is opposite of rational numbers. This is not a rational number. Hence, it is irrational number. All right. So the numbers of the form, square root of 2, square root of 3, square root of 5, etc. There are many such examples are called irrational numbers. So the collection, so how many irrational numbers exist? Infinite. Okay. So there are many numbers that exist, right? I will, I will be teaching you as to how to calculate the irrational numbers later. But there are many irrational numbers that exist. Okay. So the collection of rational numbers together with the irrational numbers, right? This collection is called as real numbers. So the moment we combine irrational numbers and rational numbers, the number line is complete, which means this is all the kind of numbers that you will be able to find in a number line. That is why the number line is called as real number line. Okay, so we state it as, for simplicity, just number line, but the real terminology is, it is called as real number line. Okay, and each point in the number line represents an unique real number. Okay, so real numbers are, they can be rational numbers, they can be irrational numbers. So since we had seen so many different types of numbers, we can say that natural numbers, all natural numbers are real numbers. All whole numbers are real numbers. All integers are real numbers. All rational numbers are real numbers. All irrational numbers are also real numbers. So the collection of all these numbers together is called real numbers, and when we represent it in the form of the line, it becomes a real number line. Okay, so the real number line or the number line constitutes only these many different types of elements, right? You have rational numbers, you have irrational numbers. Okay, good. So when we again further talk about rational numbers, right, there could be scenarios when you might be asked to represent a particular decimal fraction, right, in the form p by q. For example, let us take this particular question. You are asked to represent 0.33333 etc. recurring, okay, in the form p by q. See, when you have any pattern that is recurring, okay, 0.333, here 3 is recurring, right, in this question. So how do you represent it? See, you cannot be writing 0.333 10 times or 100 times and then put this dot dot dot, to show that it is continuing. That is very tedious, isn't it? So there is a nomenclature. What you do is you put a horizontal bar on top of it. Okay, so you put 0.3 and then put a bar. So what that bar signifies is 3 is repeated infinitely, okay, or indefinitely. It doesn't terminate. Alright, so you have 0.3 and the bar, which means 3 is recurring indefinitely. Okay, now you have to represent this in the form of p by q, where q not equal to 0 and p and q are integers. This is the definition of rational numbers. So how will you solve this problem? Okay, first you put x is equal to 0.333, right? Or you can say x is equal to 0.3 with the bar. Alright, but always when I say bar, you remember that 3 is repeated indefinitely. Okay, now you multiply both sides with 10. Okay, because here one number is being repeated, hence you multiply with 10. 10x is equal to 10 into 0.3, which is recurring. Alright, so you will have 10x equal to 3.3 recurring. Alright, so how can you write 3.333 etc., which is not ending? You can write it as 3 plus 0.3333 etc. Right? We already have defined in our first line x is equal to 0.3333 etc. Right? It is infinite. So here in our earlier statement, we are saying 10x is equal to 3 plus 0.3333. So instead of 0.333, you can put x. So 10x is equal to 3 plus x. Now subtracting x on both sides, you get 9x equal to 3. Now divide 9 on both sides. X is equal to 3 by 9, or it is equal to 1 by 3. See how you have represented a rational number in the form p by q. Right? There are many such examples that you can go through so that you get this concept very clearly in your mind. So we kept on telling that rational numbers are numbers whose decimals either terminate, or if they do not terminate, then they recur. Either one number will repeat or a block will repeat. Okay, so such numbers are called as rational numbers. So this is another definition of rational number. So if you have to figure out if a particular fraction is a rational number, all you have to do is just divide it, right? And when you divide it, if you have a non-recurring decimal, you will find that a pattern will be there. A block will keep repeating. For example, you divide 1 by 7. Okay, you divide 1 by 7. You will find that there is a block of 6 numbers that will keep repeating. Alright, so either a block of number, a collection of digits will keep repeating, or one number will keep repeating if the decimal is non-terminating for a rational number. Otherwise, the decimals will terminate. In the case of irrational numbers, it will not terminate. Decimals will not terminate, and you will not find any block or one single number repeating. You will not find a pattern. Alright? So this is how we differentiate between rational numbers and irrational numbers. Okay? So in our next example, we will see how to map a rational number onto the number line. Alright? So please wait for the next video. In case if you have any doubts, right, you can always write to askmentorguru@gmail.com. We will respond back to you by email. Alright, so I'm sure that there could be some questions in your mind. Please feel free to write. And if you find this video useful, if you find that you are able to follow this video and you feel that your friends also should gain access to these videos, kindly share the video, subscribe the video, and press the bell button. Alright, so thank you very much. We will meet in our next video. Until then, bye bye.